Hello students, welcome back to my channel Maths Insider. Today's topic is all about relationship between zeros and coefficient of the polynomial. Let's get started. What you will going to learn from this video are what are the zeros of a quadratic polynomials. So quadratic polynomials is one with degree 2 and therefore they have two zeros. Secondly, how we'll formulate the relationship between the zeros and the coefficients of the quadratic polynomial and how to solve the exam questions easily. So watch carefully till end. Now let's get started. First, let us recall the general formula of the general form of the quadratic polynomial in terms of, in a general form. This is given by ax square plus bx plus c. So this is the form and of the quadratic polynomial. So this is a polynomial of degree 2 because the variable x have the highest power of 2, which is whole number, and therefore this determines that this particular polynomial is a quadratic polynomial. Here a, b and c are constants and a should not be equal to 0. That is the most important condition for this kind of polynomial. Now this type of polynomial has two zeros. For this above quadratic polynomial, it will be always has two zeros. Let us call these zeros as, we can call these zeros of the polynomial as, say, alpha, which is a Greek letter, and beta is also a Greek letter. So we are denoting these two zeros as alpha and beta. Now the main formula which we will going to found it out, or we can able to show you that what is the main formula of this particular quadratic expression. There are two very important formula. That is formula 1, which is given by sum of the zeros, and this will be given in terms of the different constants like a, b and c, which is there in this polynomial. And number 2, it will be given by alpha plus beta equal to minus b by a, and formula 2, which is the product of zeros in terms of a, b and c, it is given by alpha into beta, which is equal to c by a. So this is the relation between the sum of zeros and the product of zeros with all the constants associated with the polynomial. This formula helps us find the relationship between zeros and the coefficients of the polynomial. Now let's prove the above formula. Now let's px equal to ax square plus bx plus c, which is the quadratic polynomial. Now to find the zeros of the above polynomial, what we need to do? We need to make this polynomial equal to 0. So px should be equal to 0. So ax square plus bx plus c is equal to 0. Now we are multiplying 4a to both the side of the equation, and therefore we will get 4a times ax square plus bx plus c is equal to 4a into 0. Then 4a square x square plus 4abx plus 4ac equal to 0, using the distributive property of multiplication. That is a into b plus c is equal to a into b plus a into c. Similarly we are using here. Now we add b square on both the sides of the equation, and what we'll find, 4a square plus 4abx plus 4ac plus b square, and we are adding another b square in the right hand side, and hence we are rewriting as 4a square plus 4abx plus b square plus 4ac equal to b square. Now we see that 4a square x square plus 4abx plus b square takes the form of a plus b whole square. We can write it like this as shown. So we are taking it in such a way it forms a square, and we are taking 4ac on the right hand side, so its sign changes. So the left hand side expression takes the form of a plus b whole square, which is a square plus 2ab plus b square. So now we can write 2ax plus b whole square, this whole thing, which takes the form of a plus b whole square equal to b square minus 4ac. Now taking the square root on both the left hand side and the right hand side, we get 2ax plus b equal to plus minus root over b square minus 4ac, or we can write as plus minus b square minus 4ac to the power half. Now 2ax becomes, we are taking b from left to right and the sign changes from plus to minus, so it becomes x equal to minus b plus minus root over b square minus 4ac by 2a. So there are two zeros for the given polynomials, and they are, say, for ax square plus bx plus c, and the zeros are, say, alpha, which is minus b plus root over b square minus 4ac by 2a, and another is beta, which is minus b minus root over b square minus 4ac by 2a. So these are the two zeros of the given polynomial, and if we substitute this in this ax square plus bx plus c, it will become equal to 0. Now let us take the sum of the zeros. So alpha plus beta equal to, I am adding the expression minus b plus root over b square by minus 4ac by 2a plus minus b square minus 4ac by 2a. So in the denominator of both the fraction, the LCM is 2a, which is common. Therefore a alpha plus beta is equal to, in the numerator we can write minus b plus root over of b square minus 4ac, plus and minus become minus b, and minus and plus again become minus root over of b square minus 4ac, and from here this root over of b square minus 4ac plus and minus will be deducted, so alpha plus beta is remain with minus 2b by 2a, 2 get cancelled, it become minus b by a. Therefore alpha plus beta is equal to minus b by a, which hence we have proved it. Similarly, let's take the product of the zeros of the polynomial. So we get alpha into beta, which is, again we will take the zeros, minus b plus root over of b square minus 4ac by 2a, and multiplied with minus b minus root over of b square minus 4ac by 2a. So we are multiplying these two expression. Let's see what we'll get out of it. So both are minus sign, and here minus we are taking common minus, so this become root over of b square minus 4ac minus b, and this become equal to root over b square minus 4ac plus b. So these two expression will take the form of a square minus b square. If you see clearly, it will take the form of a square minus b square, which is a plus b into a minus b. So therefore, and 2a we will multiply with each other in the denominator. So alpha plus beta equal to minus b square minus 4ac is root over b square minus 4ac square minus b square, and here in denominator we will get 4a square. Now since we are squaring, so square root will be removed. It will come with b square minus 4ac minus b square divided by 4a square. So b square and plus b square minus will cancel, and outside minus and inside minus 4ac become plus, and we'll cancel 4a with 4a square, and it becomes c by a. So therefore what we got, alpha into beta, or the product of the zeros, is equal to c by a, hence proved. So we have proved both the product, both the sum of the zeros as well as the product of the zeros. Now let us take an example. So find the sum and the product of the zeros of the quadratic polynomial 2x square plus 5x plus 3. Solution, it is very easy. Once you know the formula, we have to only find out a, b and c. So here a equal to 2, b equal to 5 and c equal to 3. Now we have to find the relationship between the zeros and the coefficients. So find the sum of the zeros are alpha plus beta, which is minus b by a, that is 5 divided by 2 minus, and find the product of zeros, which is alpha into beta, that is c by a, that is 3 by 2. So sum of the zeros equal to minus 5 by 2. So it's mistakenly happened. It will be minus 5 by 2, and product of the zeros is 3 by 2. So that is the answer. Now let us take another example. So this is very scoring, and once know the formula of the relation between the sum of the zeros and the product of the zeros, you can easily find out. So in the board exam, find the sum and the product of the zeros. Just find a, b and c correctly and apply the formula. Let us quickly revise what we have learned so far. So what we have learned, for a given quadratic polynomial, ax square plus bx plus c, which is a general polynomial of degree 2, the sum of the zeros is given by minus b by a, and number b, the product of zeros given by c by a. So in the next video, we will going to learn about how to find or how to form a quadratic polynomial when zeros are given. So please share and subscribe with your friends. Thank you. See you in the next video.